Use implicit differentiation to find the first derivative, then calculate the slope of the tangent line at the given point. So implicit differentiation means that we do not have to solve the equation for y, but instead we can just apply the derivative to the left side and the derivative to the right side. Now, there's many ways that you can do implicit differentiation as far as dx and dy. Let me explain a little further. Whenever I take the derivative with respect to a y term, I will always include a y prime, or you can write dy over dx. Whenever I do the derivative with an x term, I will leave off the dx. Why? Because I have it built into my y prime, or I'm carrying around my dy over dx. This is the same method as every time you do the derivative of a y term, you put dy, and every time you do the derivative of an x term, you put dx. Then you get all your dy's together on one side, all the dx's together on another side, and then you solve for dy over dx. I am bypassing a few steps by automatically putting the dy over dx and calling it y prime. And I only bring up y prime when I do the derivative of a y term. So I'll look over here, and I have 9 times xy. I'll pull the 9 out, and then I have x times y. That should be product rule. This is just a derivative of x, and this is just a derivative of y, and then of course this will be a derivative of a number. So let's do product rule first. So the derivative of the first one is 1 times regular second plus derivative of the second. Well, the derivative of y is also 1, but because I'm doing the derivative of a y term, I have to attach my y prime, then multiply by the original first. Again, you can carry dy over dx, or you can carry dx and dy, and then get your dy over dx at the end, your choice. Minus 4 times the derivative of x, which is 1, plus 1 times the derivative of y, which again is 1, but because I'm doing the derivative of a y term, I'll attach y prime, equals, well, the derivative of a number is 0. So now let's clean this up. I have 9y plus xy prime minus 4 plus y prime equals 0. I'm gonna get my y terms together and move everything else to the other side. I'm gonna factor out my y prime. Then I'm gonna solve for my y prime. Remember, that's the same as dy over dx is equal to 4 minus 9y, all divided by x plus 1. We can find the slope of the tangent line by plugging the following number in for x and this number in for y. So we'll have y prime equals 4 minus 9 times negative 4 over 17, all over negative 2 plus 1. We end up with answer of positive 4, 104 over 17. So let's recap. Remember, implicit differentiation does not require you to solve for your y separately in your equation, but instead we just have to take the derivative. We have to be careful with the derivative rules. If it's product rule, because we see a multiplication, we have to do product rule. I like to carry around the y prime term whenever I do the derivative of a y term. I find it easier and less messier, because if I carry the dy separately than the dx, I can make all kinds of small arithmetic mistakes, because we're all humans. So I like to bypass any of those mistakes by using y prime. Then we can calculate the slope of the tangent line by plugging in the x and the y into whatever the derivative is. And if I went further and asked you for the equation of the tangent line, we would use point slope, and we'll use y plus 4 over 17 equals 104 over 17 times quantity x plus 2. Of course, if you wanted to put this in slope-intercept form, you could. You just got to go ahead and simplify it. All right, hopefully this was helpful.